In this video, I will simplify a Boolean expression using Quine McClusky method. Using Quine McClusky method, simplify expression f of PQRS where the min terms are 0, 3, 5, 6, 7, 11 and 14. Write the gate diagram for the same. So now we'll try to simplify this given function f using Quine McClusky method. So first let me write the given min terms in terms of binary. The given function is f, which are having 4 variables, that is p, q, r and s. Let me assume this is MSB bit and this is LSB bit. So the first min term is m0, which can be represented in 4 bits in binary as 0, 0, 0 and 0. Next we have m3, which can be represented in binary as 0, 0, 1, 1. Next we have m5, that is 0, 1, 0, 1. Next we have m6, that is 0, 1, 1, 0. Next we have m7, 0, 1, 1, 1. m11, that is 1, 0, 1, 1. m14, that is 1, 1, 1, zeros. So in Quine McClusky method, we are supposed to represent these min terms into different groups. That is our first step. Let me write step 1. So in step 1, these min terms are represented in different groups. I will consider the first group, I will call it as group 0. Group 0 is the one where we have to consider the min terms which consists of only zeros. So that is m0. So that is 0. m0, that is min term is 0, which consists of 4 zeros, that is 0, 0, 0, 0. So this is P, Q, R and S. Next we have to consider group 1. I will call it as group 1. So in group 1, we have to consider the min terms which are having single ones. So by observing here, we don't find any min term which is having single one. So I will ignore this group 1. Now I will write group 2. Let me make it group 2. So group 2 is the one we have to consider the min terms which are having 2 ones. So here in M3 we have 2 ones. In M5 we have 2 ones. In M6 we have 2 ones. So 3, 5, 6 will fall under group 2. That is, first one is 3, that is nothing but 0, 0, 1, 1, 0, 0, 1, 1. Next one is 5, that is 0, 1, 0, 1. Next one is 6, that is 0, 1, 1, 0. So now let me write group 3. Group 3. So group 3 is the one where we have to consider the min terms which are having 3 ones. So here in M7 we have 3 ones. In 11 we have 3 ones. In 14 we have 3 ones. So 7, 11, 14 fall under group 3. Now let me represent that. 7, that is 0, 1, 1, 1. 11, that is 1, 0, 1, 1. We have 14, that is 1, 1, 1, 0. So now let me write the partition, that is this is group 0, this is group 1, group 2 and this is group 3. So after this, in Quine McClusky method, we are supposed to go for step 2. I'll tell you what to do in step 2. Let me write step 2. So in Quine McClusky method, in step 2, we have to compare group 0 with group 1, group 2 with group 3 and so on. So if here there is no group 1, so we have to ignore that. Now we have to compare group 2 with group 3. That is, each number of group 2 is compared with each number of group 3 and we have to compare where the bit is differ by only 1 bit. For example, here I will compare 3 with 7, that is 3 with 7. In 3 and 7, we can see that it is 0, 0, 1, 1. Here we have 0, 1, 1, 1. So first bit 0 is same. Here it is 0. here we have 0. So here first bit is 0, here also the first bit is 0. Here we have 0, but here we have 1. I will mark this. This is 0 and this is 1. So next bit is 1, here also 1, here it is 1, here is 1. So it is differ by 1 bit in second position. So I can represent it as 3 and 7, that we supposed to write here as 3, 7. We are comparing 3 with 7, so we supposed to write 3, 7. So it is differ in second bit. First bit is same, that we supposed to write as it is. So in second bit either it is 0 or 1. So I will mark it as dash. The dash indicates it's a don't care. Means its value is either 0 or 1. It's not definite. Next two ones are same. I will write it as it is. So as we know, here 3 is compared with 7. So we have to put check mark to 3 as well as 7. So now let me put check mark to 3 and 7. I will remove this. So I will put check mark to 3 and 7. Now I will compare 3 with 11. So if I compare 3 with 11, we can see that in the, remove this, in first bit here it is 0 and in 11 the first bit is 1. So it is differ by 1 bit. In second bit it is 0, 1, 1. Here also we have 0, 1, 1. So it is differ only in MSB bit. So now I have compared 3 with 11. So we supposed to write here 3 and 11, where the first bit is differ, that we have to represent it as dash. Remaining bits are as it is, that is 0, 1, 1. 0, 1, 1. So now we have compared 3 and 11. We have to put check mark. 3 already there is check mark. Now I will put check mark to 11. Similarly, now I will compare 3 with 14. So if I compare 3 and 14, it is differ by 3 bits. As we know, here the first bit is 0, here it is 1, that is one difference. Here it is 0, here it is 1, that is second difference. Here it is 1, here it is 1, that is same. But in here it is 1, here it is 0, that is third. So here it is differ by 3 bits. So we should not consider 3 and 14 because it is differ by 3 bits, not by 1 bit. Now the same thing is repeated with 5 with all other 3. Now I will compare 5 and 7. If I compare 5 and 7, as we know it is 0, 1, 0, 1. Here it is 0, 1, 1, 0, 1, 1. So it is differ in this bit. So this can be represented as 5 and 7. I will write it as 5, 7. Here it is differ by this bit. First two bits are as it is, that is 0, 1. Next bit is dash. Again last bit is 1. After doing this, we have to put check mark to 5 and 7. So already there is a check mark for 7. Now I will put check mark to 5. Remove this. Now I will compare 5 with 14. So if I compare 5 with 14, the first bit is 0. Here first bit is 1. So there is 1 bit difference. Second bit is 1 and here second bit is 0. So again here it is difference by 1 bit. So total it is difference by 2 bits. So we have to ignore it because it is differ by 2 bit. Now I will compare 5 with 14. So here in 5 and 14 there is 3 bit difference. So we should ignore it. Now I will compare 6, minterm 6 of group 2 with each value of group 3. So if I compare 6 and 7, it is differ by 1 bit at LSB. So I can represent 0, 1, 1, 6 and 7. I will write it as 6, 7, 0, 1, 1 is same, 0, 1, 1. It is differ by LSB. I will put dash here. Now we are supposed to put check mark for 6 and 7. 7 already is there. I will put for 6. Now I will compare 6 with 11. So by observing here the first MSB bit is differ and second bit is also differ. So we should ignore it. Now compare 6 with 14. If I compare 6 with 14, MSB bit is differ by 1 bit. Rest it is 110. Here also it is 110. So it is differ by 1 bit. So we are supposed to represent it. 6 and 14, it is differ in MSB, that is dash 110. So now again we have to put check mark for 6 and 14. 6 and 14. So now we have compared all the adjacent groups. So we have to stop this process. The next step in Quine McClusky is we have to identify the numbers which are not having check mark. So here this is the number which is not having check mark. So this is one of the prime implicant, and here we can see that these all are prime implicants. So now let me write the prime implicants list. That is, I can write list of prime implicants. So here there is no check mark, so it is prime implicant, that is P bar, Q bar, R bar and S bar. That is, I can write M0, that is P bar, Q bar, R bar, and write this one, that is 3 7. I can write 3 7. I'll write only 0 3 7. So here 3 7 can be represented as, here also the first number is P, Q, R and S. So it is P, that is 0. It means it is P bar. We have to drop this Q, and it is R and S, that is P bar, R and S. Next we have 311. 311. The value is Q bar, R, S, that is Q bar, R and S. Next we have 5 7. 5 7. That is P bar, Q, S. P bar, Q, S. So next we have 6 and 7, that is 6 7. Its value is P bar, Q, R, that is P bar, Q and R. 6 14. Its value is Q, R, S bar. Q, R, S bar. So these are the 6 prime implicants. Now we'll try to find the essential prime implicants. Now the next step in Quine McClusky method is we are supposed to write the implicant chart. The implicant chart consists of all the prime implicants and all the minterms given in the problem. So a list of prime implicants, that is, the first one is 0, that is nothing but P bar, Q bar, R bar and S bar. Now let me write, this is 0, which is respect to P bar, Q bar, R bar and S bar. Next we have 3 7 P bar RS, that is 3 7 P bar RS. Next Q bar RS, that is 311. 311 Q bar RS. Next is 5 7 P bar QS. P bar QS, that is 5 7. Next is 6 7, that is P bar QR. P bar QR 6 7. Next we have 6 14, that is QR S bar. QR S bar, that is 6 14. So this is row wise. So in column wise we have to represent all the minterms which are given in the problem. That is, the minterms given are, here we can see, that is 0 3 5 6 7 11 14. These we supposed to write here. That is 0 3 5 6 7 11 and 14. In Quine McClusky method, now let me consider 0, that is P bar, Q bar, R bar, S bar. So this is 0. So this is 0. We have to put cross mark here like this. So here it is 3 and 7. It covers the minterms 3 and 7. That is, in 3 and 7 we have to put cross mark like this. So next we have 311. Again there is the 3, and here we have 311. Next we have 5 7, that is 5 and 7. Next we have 6 7, that is 6 and 7. Next we have 6 14, that is 6 and we have 14. So next in Quine McClusky method, we supposed to observe the column which is having single cross mark. So here we have one cross mark, put the circle like this. So in this column there is only one cross mark, put the circle for this. And here we have one cross mark, put the circle like this. And here we have one cross mark, put the circle like this. So these all are known as essential prime implicants. So the next step in Quine McClusky is we have to consider the essential prime implicants. So here it is covers 0 minterm, put the check mark for 0. Next, consider this essential prime implicants. It is with respect to 5 and 7. So here minterm 5 is covered, 7 is covered. Next we have this essential prime implicants, its value is 3 and 11, that is 3 and 11. So here next one is 6 and 14, that is 6 and 14. So here we can observe that all the minterms are covered. So only we have 4 expressions. Now let me write those expressions. Those are nothing but essential prime implicants. So the value of simplified Boolean expression f will be equal to, that is this essential prime implicant with respect to p bar, q bar, r bar and s bar. Now let me write p bar, q bar, r bar and s bar, plus here we have p bar, qs, p bar, qs. Next we have this is essential prime implicant, that is q bar rs plus q bar rs, and this is the circle, it is with respect to qr s bar plus qr s bar. So this is the simplified expression. Now I will try to verify this using K-map for understanding purpose. Now let me simplify the same minterms using K-map. So this is the 4 cross 4 K-map. Let me consider the variables. Here is PQ, here it is RS. So 0, we have 3, minterms are 5, 6, we have 7, 11, 14, 11 and 14. Remaining cells are zeros as we know in K-map. So now let me simplify this. This and this I can make a pair. The value of this will be, we can see in these two columns, one is common which is with respect to S, and with respect to this row it is 0, 1, that is P bar Q and it is S. P bar Q and S. So now here this one and this one I can make it as a pair, that is this one and this one. So the value of this is, here it is RS, that is RS, and between this row and this row, that is 0, 0 and 1, 0, here common number is 0 which is with respect to Q, that is Q bar RS. So now here using these two ones I can make a pair. The value here it is with respect to R S bar, it is R S bar, and here between these two rows the common term is 1 which is Q, that is Q R S bar, and here we have one more one which is independent. So its value is P bar, Q bar, R bar and S bar, that is P bar, Q bar, R bar, and so here the Boolean, the simplified expression is F is equal to, we have P bar, Q bar, R bar, S bar, plus we have Q R S bar plus P bar QS plus we have Q bar RS, Q bar RS. Now let me compare. So here it is P bar, Q bar, R bar, S bar. We have P bar, Q bar, R bar, S bar. Here we have P bar QS. We have P bar QS. Then we have Q bar RS. We have Q bar RS. Next term is QRS bar, that is QRS bar. So the result is verified. Also, it is asked in the question that write the gate diagram for the same. Now let me draw the gate diagram for the same expression. Now let me draw the logic diagram for this. Let this be P, Q, R and S. So let this line is P, this is Q, this is R and this is S. So let this be P bar, let this be Q bar, let this be R bar and let this be S bar. So the first term is P bar, Q bar, R bar, S bar. I will use 4 input AND gate. Here we have P bar, we have Q bar. So here we have R bar and here we have S bar. The output here it is P bar, Q bar, R bar, S bar. Next term is P bar QS. I need 3 input AND gate. The values are P bar QS. So here we have put the dot like this. This node indicates the line is coming from this variable. So next we have P bar QS, that is this is P bar and we have QS. So this is Q line, this is Q and we have S. So this is S. So the output here it is P bar QS. Next we have Q bar RS. I need one more 3 input AND gate. Q bar, that is this line is Q bar. So this is Q bar. We have RS. So this line is R. And we have here it is S. So this is S. That is Q bar RS. Next we have QRS bar. I'll use one more and 3 input AND gate. QRS bar. That is this line is Q. We have Q, R. This is R. And we have S bar. So here this line is S bar. The output is QR S bar. 4 input OR gate. The output, all these are connected to here. So the output of this is F. This is how we're supposed to simplify using Quine McClusky method.